gentlemen, I would like you to take a few minutes, maybe 2 minutes here, and just introduce yourself to everyone who's viewing this conversation. So, Taya, do you want to begin?
I'll defer to the Mekonnen.
Okay.
All right. My name is Mekonnen Kassa, and I'm not sure what you like me to say. Just talk about myself and my professional background, or is that it? Or is there some things that...
Yes, just talk about who you are and what your current role is.
Okay. I am originally from Ethiopia, and I have lived out here in the U.S., specifically in Seattle area for about 30 years. And I currently work for Microsoft, and I'm a director of cloud security engineering at Microsoft. Yeah.
Awesome. My name is Adesanya. I currently work for Synopsys. We are an IP and EDA tools provider. So in short, we help companies build chips that help drive any electronics that you see, whether it's aerospace or your phone, your laptops, any type of consumer, industrial, medical devices. We help provide the IP that's inside those chips that make them drive. My background is I went to Purdue University for electrical engineering technology, moved over to Arizona to work for Semiconductor, which is a chip supplier. And then while I was there, I got my MBA at Arizona State before moving here to the Bay Area to take a job in the IP industry. So, thanks for having me.
Of course. So you both have very interesting roles, and I want you to start off by telling the audience how you got into the roles that you're currently in today.
You want to take this one first? Or I'll take it.
I think, Deena, it would be good if you call the name and say, hey, Mekonnen or Tayo, take this.
Right.
That way we...
Okay. I will.
Yeah, so how I got into this role. Okay, so when I was at Purdue University, I was very into electronics, all types of electronics. I loved hacking into iPhones and being able to work on different types of computers. And I learned more and more about how a system kind of operates at the hardware level. And I was like, all right, if I'm gonna do anything, it's gonna be surrounding electronics. And then I found the sales role to be a little bit more engaging because for me, I wanted to be around people. I wanted to continue to build relationships, and I found that role allowed me to do both. And so I went to what it's called a just-in-time job fair. I researched the different companies that was there, and Semiconductor was one of them. Interviewed, they flew me out to Arizona, had a good time, figured that this was definitely something I wanted to do long term, and they took a chance on me. And it's funny because most of the time, sales engineers, they usually have to go through some training program, but there was a unique situation, they had a need, I kind of met that need, and I begun there. And how that translated me to coming into the Bay and getting into AI. Well, after getting my MBA, I wanted to just take on larger accounts, household name accounts, customers like Apple and Google and Microsoft, of course, as well, and try and be a supplier to those companies that would build products. And I felt like they were doing most of the volume in the world, being in Silicon Valley. So that prompted me to move to that area. And as I began to grow and develop and learn about these products, I started getting more and more into computer architecture. So, for instance, when you go to Best Buy and you're looking for a new laptop, right, you'll look at the speed, you look at how fast it processes things, and you might look at the i3, i5, i7 from Intel see what kind of level of computer you need for the price point. So the core chip is the CPU that makes that possible for the laptop. And so I wanted to start selling those type of products. And I had to, really just translate from just learning and understanding regular other chips, whether they were, chips that centered around power and sensing, to really understanding more about the core and how computer processing works. And so I just took 3 months to learn more about computer architecture, and then I applied. I knew somebody that knew somebody, and we had a conversation. Turned out to be a decent fit, and they welcomed me in. And so I've been at Synopsys for around 6 or 7 months now. And it's opened my eyes to a lot more about AI in terms of computer vision. When you hear about the Tesla being able to drive itself, it's got to really understand the environment and make decisions in real time. And so those are the things that I'm working on, being able to sell and help customers, be able to build those type of systems.
And Mekonnen, how did you get into your current role and exposure to the AI space?
Thank you, Deena. I just have to give you a little bit of background, a little bit more background, so that I can contextualize it. I am, as I said earlier, I'm originally from Ethiopia. And I was actually at a refugee camp in the Sudan and had an opportunity to come in and live in the US about 30 years ago. So I hardly spoke a word of English. I didn't even know anything really, because I grew up in a very small town in Ethiopia. Here, some people helped me get a driver's license, and I was a cab driver. So I drove a taxi cab in Seattle for about 5 years and started taking English as courses at a community college, and eventually transferred to University of Washington and studied mechanical engineering. The reason I did that is because the very few Ethiopians who were living at the time said to me, hey, you don't know anybody, just go study engineering and you'll find a job. I said, cool, I'll go do that. But by the time I was about to graduate, I just didn't want to be an engineer. As a matter of fact, as you may have probably noticed, I'm a very social person. I'm very animated. I love to talk to people. So I would have been, and I'm very political. So I would have been a lawyer or something like that. But, I was just boxed in to do engineering. Fortunately for me, while I was driving a cab, I was talking to the passenger white man, Canadian. And I was driving him from downtown Seattle to the airport. And I said, sir, where are you going? He said, I'm flying to Vancouver, British Columbia. I said, why? Why don't you drive? It's just an hour and a half. He said, no, I'm a consultant. I do this every week, so I'm tired of flying. I mean, driving. I said, what's a consultant? What do you do? Then he proceeded to tell me about, this was in the mid-1990s, about computers and business process engineering, consulting, automating, and all that. And I said, wow, I love what you do. I want to do what you're doing. He said, Kavi, you? I said, yeah. I'm actually going to University of Washington, blah, blah, blah. So one thing led to another. He gave me his business card. And the next Monday, I took him out to lunch. He actually helped me write my resume, and then told me to go give it to the Anderson Consulting office. Right now, they call themselves Accenture. So I went there and gave my resume there. And then I had to go downtown Seattle, learn how to buy a suit and put it. As a matter of fact, the salesperson loosened up the tie. So because I never wore a suit and tie before. And when they called me for an interview, this person would call me and tell me who was going to interview me and the likely questions they will ask me and what I should how to answer. Then he will give me questions as well and say, ask them like this. So I eventually got the job with Anderson Consulting. And then they sent me to Chicago for about 2 weeks to learn Java programming. I did. And then my first project was at Microsoft. I was a consultant at Microsoft, and they put me on this development project. I don't know how to do that, just a little bit. So they said, don't worry, we'll give you 3 months. We're not going to charge Microsoft. You will be here and learn that. So in 3 months, I learned Visual Basic 4.0 programming. right? As they say, the rest is history. After that, I just started working there and consulting, and went and consulted somewhere else. And then eventually came back to Microsoft as a full-time employee about 13 years ago. And recently, since I've been working in the infrastructure space and everything moving to the cloud, and I moved into the cloud space, and then there was this really tremendous opportunity in the security space. And I said, wow, when I looked at what's really going on in the industry, you can see that everything is moving to the cloud. Cloud is really, the cloud service is becoming the computer of the world, right? So I said, eventually what's going to be left would be security and networking. Everybody's going to need security. Everybody's going to need networking, but the infrastructure can be hosted anywhere else. So I reached out to people about opportunities there. They said, hey, do you have a certification? I said, I don't have any certification. And they told me, can you get some security certification? And they told me about CISSP. I said, sure, I will get it. I didn't even know how hard it was, but it took me 2 weeks. I had to study almost 18 hours a day for 2 weeks and passed the exam and got my certification, and I got the job. So now I am actually leading a security engineering team at Microsoft.
Yes, so you both have very unique stories, and two things that are very similar to both of your stories, or actually there's three things. One, that you guys just jumped into the space. You took a chance, like you said, you had to study for 18 hours to get a certification. Yeah, you just jumped in and studied and learned along the way. So I just want people who are watching to know that you can get into tech and get into these industries as long as you put forth the effort. And another thing for both of you, a lot of times people think that techies are quiet and reserved. No, you both love people. You both love to have a conversation. So I just want to note that even in this space, there's a variety of people that you'll interact with. And to continue on with the topic, so we keep mentioning AI, but what exactly is AI? I want to just take a moment to define it and explain to people what is AI and how you currently see it being used in society. So Mekonnen, do you want to start?
Absolutely. I think, is not for coming up with easily to understand words, right? I mean, we talked about cloud. What's cloud? I spend so much time explaining what cloud is to artificial intelligence is also the same thing. It's been really around for hundreds of years, right? 1500, 1500, 1700. What it means is, look, we look at something, think about it, and do something, right? Instead of us, just you program machine. Understand, do something on your behalf. So it has its own evolution, of course, but it started like that. Really, if you look at the calculator, even the computer you're using, they're all artificial intelligence. They are.
Yeah. So, in a nutshell, I think of AI as computer systems that replicate tasks that normally are performed and require human intelligence. So if you think about like visual perception, speech recognition, like being able to understand what someone's telling you, and then obviously decision making. Those are some of the examples, but that's how I would define AI.
How do you see it being used? From my perspective, at my job, I work at a consulting company called Mekonnen Kassa. We've been working on, for our clients, like contact center AI, especially given, COVID-19, everybody's kind of in the house. So you need someone communicating on a constant basis. How do you see AI working currently?
Man, AI is everywhere. I mean, and sometimes you may not even realize it's being used in a lot of different systems or devices. But the one example I had from earlier is like, your Tesla or your autonomous vehicles. Being able to be in a car and safely depend on the computer system within the car to navigate you to where you're trying to go to, and avoid situations that will put you in danger. And so that's a basic example of of AI being used. I think when it comes to retail, being able to dig deeper into the typical consumer or a given consumer and instinctively serve them something that might be of interest to them. The way in which Facebook shoots you ads that they think you would like. It's might be based on some of their pages and things that you visited in history, and then you replicating that and positioning something that you as a consumer might want to bite on.
You know what a perfect example of that is? I think Dawn Dixon too, but she has
Sure.
Popcom, and drawing all the consumer information and putting product in front of them that they would want to buy is a great example of a good use of AI.
I mean, even from a security standpoint as well, like being able to identify who you are as a person, and then use that as a security protocol to be able to make a transaction. That's absolutely another version of AI being used in application.
Right. And often with AI, we hear the words machine learning and deep learning. And so I want to take a moment and just define those words, and then also talk about the link between everything and how the whole concept works in the real world. So Mekonnen, I see we have you back. Do you want to take that question?
Yeah, I'm sorry. I don't know what happened. I got disconnected. So I think, thank you. That's a good question. So I've tried to define, at least at a very high level, what artificial intelligence is, right? You create something to be intelligent. Then when you talk about machine learning is, instead of you programming it, right? Earlier we talked about you actually coding some kind of algorithm, right? And feeding data to this machine, whether it's a computer or a robot or whatever, and asking it to do something on your behalf, right? So for example, you can actually program something to drive a car, right? There is a computer, right? Artificial intelligence, it will drive a car, but it knows how to drive a car. But that machine that you have programmed to drive a car cannot play soccer, for example, right? It's not versatile, right? You tell them to do something, they will do that very well for you. But when you start talking about machine learning, right, it starts to cross that boundary and try to say, hey, instead of actually you programming it to do something, it starts to learn by itself, right? You give it some kind of data, mostly data, and it starts to identify a pattern by itself and say, aha, I see a middle-aged, a person, it can look at me and say, hey, this is a middle-aged black man, right? Or something like that. It can actually identify patterns and then start to learn. That's why they call it machine learning. It actually learns instead of you programming something to tell it to do something. And then deep learning is another evolution of that, right? I think something that they keep talking about is AlphaGo that Google did, that actually played the Go game, that 14x14 Chinese game, right? It's one of the most complicated games in the world. So what this machine that they created did is, it started to play for the first time with a person, and the machine lost. But after that person went home, the machine kept playing the game by itself. And when that person came in the morning, the machine won the game hands down. So when you talk about deep learning, that's just another evolution of that. So you've got artificial intelligence, something that you actually program and ask it to do something, and then a machine learning when actually the machine or the something that you created start, with a sort of a neural network, right? You kind of give it a human-like brain architecture so that it can start to learn, just like a baby learns, right? And deep learning would be another evolution of that. So that's how I describe it.
I second that. I mean, artificial intelligence, you have as an overlap, right? Any technique that enables a computer to mimic a human. And then you have learning that's a subset of AI that includes techniques that enable the machine to improve the task and experience And then you have deep learning, which is kind of a subset of machine learning as well, that involves what we call neural networks. And when you think of a neural network, you can kind of think about the brain and how it takes different layers of algorithms or decision-making tasks and connects them together to be able to create the output, right? And so for a lot of systems, you have an input, you have the task, and then you have an output, and that output usually is what gives you information or data that you can use in your system to make the overall decision for whatever it is given in your application. Hopefully that makes a little bit of sense to you guys.
And so
I think one word we could probably add, Tayo, is, I can't remember how to pronounce it, but there is this architecture called anthropomorphism or something like that. But you architect it in such a way that it has a human-like neural network, right? If you look at our humans, how do we learn? The way we learn is this event that we're having right now, you would remember it because your brain, the neural network, actually starts to expand and create new networks. That's how it stores this memory that we actually had this event, and that's how you remember. So they are trying to create machines with that kind of neural network, so that when they do something, they see something, the network actually expands and they have some memory stored that retrieve that and act like us, like a baby starts to learn from a very young age all the way to adulthood and old age.
So we have about 15 minutes left, and I did want to open it up to questions from the audience. So if you have a question that you want to ask these gentlemen, drop it in the event chat box, and I will ask them now. And if you don't have questions, that's okay too, because I have some other questions that I can ask them to give you some more knowledge on AI.
Well, while they're kind of getting the questions together, I think one main concept I want to make sure folks understand based off of this discussion is there are a few different ways that these systems are being developed, and the three segments that I've seen that are very prominent are your supervised learning, your unsupervised learning, and your what we call reinforcement learning. And so those are three different ways in which these systems are now commonly being made. And so for supervised, you got to think of it like getting furniture from IKEA. You get an instruction, you follow the instructions, the system tells it what to do, and hopefully you get the output that you're looking for. Then you have the unsupervised learning where you don't have any instructions, but you're still trying to get to the outcome that you're looking for. And then the reinforcement learning is kind of self-explanatory for the most part. You kind of figure it out along the way and give yourself rewards to get to the outcome that you're looking for in real time. That's the only thing I wanted to add to the discussion.
No, that's good. That's very well described.
Yes, we have two questions. First question for you guys is, what is the conversation that is being discussed around the negative effects of AI? So that means like protecting privacy and building in bias from data sets.
Yeah, I think there are some things that we need to be thinking about when developing AI algorithms. One of the things I think about is bias. There are certain systems, if you're not thinking of them in the context of a certain group, you could be excluding that group or treating that group differently. An example of this is when you use these AI systems to detect faces or people, and some of those algorithms, when they first started, were trained, and that's the form of learning in the system, using just white people. So like there was you got 1,000 or 100,000 white faces, and they're able to detect, the eyes and the nose and ears, and to classify those human beings. But then, you just put a bunch of random black people together, it may not work the same, because they weren't, illicitly trained to include the people's different backgrounds, and that causes problems. Now we may have somebody who thinks, well, they use the system, and the system improperly identifies a black person just because it wasn't trained to really do it well. So that happens. And then in terms of privacy, I sell security IP as well, and nothing is 100% secure. Like, we gotta understand that, but there are things that we can do to make sure that there's a certain level of security. There's security levels for health products, we call HIPAA. We just need more standards to really regulate some of these products, because if you go to Best Buy right now, you don't know what camera is going to be more secure than the next, because there's no stamp. So as an average consumer, you're not really understanding that. There's nothing to show that one is more secure than the other. But that's something I think that there's more work that needs to be done. And some of these companies are starting to realize how important it is, because, like somewhere like Target, if there's a DDoS attack where there's just like a bunch of data being overloaded to their system, and they knock out one of their cameras, or someone is able to compromise it, there's a whole bunch of risk associated with that. So companies are losing money, people are losing money, people are losing their identities and things of that nature because of that.
Mekonnen, did you have anything that you wanted to add?
Just piggyback on Tayo, he's actually described it well. I think in terms of really security and privacy, we rely on government regulations, right? As Tayo said, there are PII related, PCI DSS, PHI related, all kinds of regulations. Unfortunately, the people who actually regulate this are not technologically savvy to regulate. That's where you start to have this gap, right? So, as you may have, it's after the fact, after some data is this and that, that's when we say, oh, and even our legislators still are not up to par. So that continues to be a risk. The other risk is even the people, the engineers that are creating all these technologies don't understand security holistically. Security, as a matter of fact, I was on another session last week. Security still continues to be an afterthought when engineers are creating products. It's not necessarily an integral part of technology innovation, right? So they don't. And then on the other side, you have got these sophisticated hackers who actually make a living, right? You've got individual and state actors who are actually much more sophisticated than the engineers that are creating these products. So that risk will continue to be there. And as we have done all along, we'll continue to manage it. And then in terms of really the negative impacts of AI, of course, we have seen the movies and this and that. That's really something way out. But right now, really, I think people have to understand that whoever had supremacy of technology has always benefited, and in some instances victimized others. Tayo has tried to describe some of those incidents, right? We've heard some of the stories. Self-driving cars not recognizing black people, right? That's dangerous. And you've got this police algorithm that actually now it's forbidden from sale because it takes this criminal history, right? And then tries to predict the likely place where crime is going to be committed, and starts dispatching police officers to that neighborhood But remember, this algorithm is relying on existing data, and we don't even know how that data is created. Right? So there are those kind of things that are taking place. So it's critically important that people like us get involved in this industry and not only innovate, but also keep it in check, that it doesn't end up victimizing us like it did historically.
Very true, man. Very true.
All right. And that was very insightful answers from both of you. I really appreciate it. Unfortunately, we only have 2 minutes left, and I do have a final question that I want all of us to answer. The question is, if you can give the audience one final advice or reminder, what would it be? And let's start with Mekonnen.
Well, I think I've said it, but at least if I were to say one thing, don't hesitate from exploring, and nothing is as hard, as difficult as you imagine it to be. Right? Just take the initiative to get your proverbial feet wet, and you would know that I'm not different, Tayo is not different, Bill Gates. Those people just had the opportunity, had access, and learned about that, and got where they are. At some point in their life, they didn't know what they know now. They have to learn it somehow. So you can learn it as well.
Man, that's very true. For me, man, I kind of second a little bit of that. I think folks need to understand, like, they need to not have so much fear, like, or at least not succumb to it. When we're talking about all this AI and machine learning, it kind of can seem very, very top level above people's heads, but honestly, one article at a time, over a couple of days, over the next couple of weeks, over a few months, you start to learn and really be curious, or use your curiosity to lead you to the path that you want to go. If you have that passion for what it is you're learning, or the field that you're trying to get into, if you're really, really interested in it, nothing can stop you. Like, nothing. I was an athlete. I wasn't always like, sophisticatedly or inside this particular sector, but I changed lanes and went from, focusing on just, being an athlete to trying to really, and also trying to win championships, to like changing that passion over to tech and wanting to be the best salesperson that I can be. And I just had that focus and determination to learn it, to learn my products to a point where like no one can tell me about what it is that I'm selling better than me. And I think that's allowed me to be successful. So if you guys have that passion to learn about whatever it is you're trying to get involved in, just go into it head first and just give it all you have. There's nothing that's going to be able to like keep you from being successful except for yourself.
All right, so you both took my answer, so I'm going to switch it up a little bit and talk about mentorship. So having mentors in this particular field is so important. A lot of times when you go into jobs, especially in tech, you're not going to see a group of people that can lead you in the right direction. Obviously we want to be successful in these roles. We want to be in AI, so following your passion is great, but also make sure to network and meet the right people who can kind of be your guide or lead and give you the inside tips of how to navigate the space. I think a lot of times, like Tayo mentioned, there's a fear of being in tech and the fear of like you don't know everything. But if you have the right people around you, you network and you make the right connections, then I think you'll be successful in this field. So never fear, and make sure that you have the right network around you.
All right.
All right, that completes our time.